To build the next generation of global infrastructure, we have to carve continuous 13-meter-wide cylinders directly through solid rock and wet earth, often deep beneath ocean floors and crowded cities. Take the Mumbai-Ahmedabad bullet train project. This route requires a 21-kilometer tunnel passing directly beneath Thane Creek, navigating a dense urban skyline and a submerged, waterlogged mudflat. Historically, methods like drill and blast or cut and cover left the excavation face dangerously exposed. While that worked in rural mountains, using those same techniques beneath a modern city would invite immediate flooding and surface collapse. In this cross-section of a subterranean void, you can see the core physics problem: millions of tons of geostatic and hydrostatic pressure. The sheer weight of the soil, rock, and groundwater above is constantly trying to crush inward to fill the empty space. You cannot solve this problem by simply spinning a drill bit faster. Engineers have to actively push back against the weight of the earth at the exact same moment they are digging forward through it. This is the role of the tunnel boring machine, or TBM. It functions as a massive, moving underground factory that balances destruction and creation in a single, continuous pass. Surviving this environment requires transforming an excavation site into a highly pressurized, self-contained assembly line moving forward through the deep earth. At the absolute front of the machine sits the 13.6-meter cutter head. On the Mumbai bullet train project, this steel disc weighs thousands of tons and rotates at a slow, unstoppable 4 revolutions per minute. On this layout, the steel blades aren't the primary defense against a cave-in. That belongs to the mixed shield slurry system. Pressurized bentonite slurry pumped into this chamber forms an impermeable filter cake, perfectly balancing outward pressure against the inward crush of the earth and groundwater. As the cutter head slices rock away, integrated jaw crushers grind the debris down. The muck is mixed with the slurry and pumped through the machine to a surface treatment plant. After separating the excavated rock, the cleaned slurry is cycled back down to maintain pressure at the face. This continuous pressurized fluid loop creates an invisible shield, preventing the ocean and the city above from caving in on the machine's operators. Moving backward from the cutter head, we enter the main shield, where the tunnel's permanent structure begins to take shape. Here, a robotic setment director uses vacuum lifts to position and bolt massive precast concrete segments into a perfect structural ring. Through the semi-continuous advanced system, hydraulic jacks push off these newly built concrete rings to thrust the machine forward, digging into the earth while the tunnel lining is being installed simultaneously. At the rear of the tail shield remains a final structural threat, the tail void, a gap between the new concrete ring and the raw earth. A high shear mixer instantaneously injects cement bentonite grout into this space, locking the earth in place and preventing surface settlement. This synchronized assembly line of digging, lining, and grouting is the only way to transform an unstable hole into a permanent, waterproof structure in a single motion. Behind the shield, multi-story backup gantries roll on freshly laid tracks, carrying the power, ventilation, and slurry systems through a completely finished concrete tube. Even when operating blind, the TBM navigates with precision. It uses tunnel seismic prediction, firing acoustic shots to probe the rock mass and detect faults up to 100 meters ahead of the cutters. After months of subterranean digging, the 3,100-ton machine precisely breaches the receiving shaft, arriving exactly on target. This massive industrial operation happens in complete isolation. Down in the dark, thousands of tons of steel are tearing through rock, while on the surface, traffic flows and the city remains undisturbed. By navigating these extreme physical forces, the TBM acts as an invisible enabler of modern infrastructure, creating the high-speed links that modern cities require without ever breaking the surface.